In this video, let's solve part D of question 11. In this part, we consider the equation z squared equal to 2 times z star, where z is a complex variable and z is non-zero. Okay, the hint says that by expressing z in the form a plus bi, we can find the roots of the equation. So let's do it. So let's z equal to a plus bi, where a, b are real numbers, and a, b cannot both be 0. That means the tuple a, b is not 0, 0. Okay. Then we plug in a plus bi into this equation. What we get is a plus bi squared is equal to 2 times the conjugate of z, and it's not hard to see that z star is equal to a minus bi. Okay, so this gives us that a squared plus 2abi plus bi squared is equal to 2a minus 2bi. So a squared minus b squared plus 2abi minus 2a plus 2bi is 0. And then we combine the like term, which means that we put the real part together and the imaginary part together. So a squared minus b squared minus 2a plus the imaginary part will be 2ab plus 2abi plus 2bi, and then but we can take the common factor 2b out, so it's 2b times a plus 1i is 0. So we have a complex number that is equal to 0. This means that both its real part and imaginary part are 0. So a squared minus b squared minus 2a is 0. 2b times a plus 1 is also 0. Okay, let's call the first equation by 1 and the second equation by 2. Okay, we solve 2 first because 2 is easier to solve. So 2b times a plus 1 is equal to 0. This implies that either b is 0 or a plus 1 is 0 or both. So we discuss into 2 cases. Case 1 is the case where b is 0. So in this case, equation 1 becomes, after plugging b equal to 0 into equation 1, we get a squared minus 2a is 0. So a times a minus 2 is 0. Hence, a is 0 or 2. However, a cannot be 0 because now b is 0. And if a is 0, then ab will be 0 at the same time, which violates our assumption. So because a cannot be 0 in this case, so a is 2. Now let's look at the second case where a plus 1 is 0. So the second case will be the case where a plus 1 is 0. That is, a is equal to negative 1. In this case, the equation 1 becomes when a is -1, then the equation 1 becomes -1 squared minus b squared minus 2 times -1 is 0. So 3 minus b squared is 0. This implies that b is positive or negative square root 3. And both solutions are valid because now a and b are non-zero. And so combine the solutions from case 1 and 2. So from the previous two cases, we know that the possible solutions are 1 square root 3 or -1 comma square root 3 or -1 comma negative square root 3 or 0 2 2. Oh wait, 2 comma 0. Alright, so these are the possible solutions for AB. So the possible z to the equation will be, the solutions are -1 plus square root 3i or -1 minus square root 3i or 2. Okay, this completes the proof of part D.